on NLP, but we'll just cover some of the terminologies which are needed for NLP. Most of it you might be already aware. Anyone knows what is NLP?
Like handwriting recognition, speech recognition, those things.
Okay. Anything else?
Yeah, sentiment analysis, right?
So NLP is a branch of computer science and a branch of artificial intelligence as well, where we will cover all means how the spoken words and how to understand a text. So when we say text, right? That okay. Let's go to this and then come back to the first one. So anyone has know what is the difference between text mining and natural language processing? Any thoughts is fine.
Text mining is like we will get some insights from the texts, but natural language processing is like that I'm not sure, but it will convey some messages out of the human spoken language.
Correct. So one is the text mining is just grouping or getting information from the textual data. Whereas if we take NLP, right, it will, when you write a feedback, for example, in the review, you might write a positive comment and with a smiley. Like, my day is good, you can write and then put a negative smiley. That means your day is bad. How will the system identify it, whether which what is your mood? Same with the spoken language. So we will say, right, how is your day? So we will say, oh, my day is very good. But your face will tell it that's the bad day you are having. So those things, how to analyze, that is one thing. The second is dialects. So the way each of us speak, right? Especially means for me, people used to say I have my native accent in my language. So those language the system may not understand. So that's where they are having means that's where the importance of NLP comes in. So text mining refers to the process of extracting useful information from unstructured data. So like social media post, so it will just check whether the term good, bad is there. So that pattern recognition it will do and get some insight out of it. Whereas in NLP, it is more related to human language. So it will, with all these classification, we will be able to do sentimental analysis, language translation, speech recognition, all those things we can do with NLP. Any questions on this?
No.
Okay. This is a bigger umbrella. So this will tell you where NLP stands. So for NLP, you need a little of statistics. You need little of AI and machine learning knowledge, some computational. So the linguistic knowledge, even if you are from the literature background, you will be able to excel in the NLP because you will know how to classify the words better than all of us. So for the NLP especially, there are a lot of people joining from the proper literature background. These are some of the applications of NLP. NLP can be used for email filtering, language translation, document analysis, online searches, social media, sentiment analysis. You can go this in detail, how it is NLP is used for each of these applications. For example, in chatbots, means who, for example, for Alexa, if I ask it, it will be able to recognize my accent also. So the very initial versions of Alexa and Siri, whenever we say something, it will respond back telling, I couldn't understand. But now it has evolved to a stage that it can understand the different accents, different dialects also. These are some of the terminologies which we have learned in the previous semesters. So one is tokenization. So this is something, means whenever we do the NLP algorithms, right? We might need to, means these are some of the terminologies or some of the steps we need to use to convert it into or make some inference out of that data. So one is tokenization. So tokenization, if you are giving a huge paragraph to the system, right, we can convert it into sentence and words. For that, either we can use, means in the Python, we can use NLTK libraries for that. And we have this SCND tokenize and word tokenize. So that will convert the it means either it will split the complete paragraph into sentence, or it will split word by word if you use this tokenization.
Yeah, hi Veena. Are we recording this session? We can, if we are able to record. Maybe those who are not joined, maybe refer.
Yeah, I am recording.
Okay. Thanks. Just share the recording link in a group. Maybe people can refer them. Thanks.
Yeah, later.
Thank you.
Yeah, please continue. Sorry.
So the other terminology which we have, or other process which we have learned, is engrams. So engram is again a technique where we can split the sentence. So if there is a sentence, if we split it word by word, then it is a unigram. If we can group, for example, this is a sentence, this is a sentence. There are 4 unigrams in it. And if I'm splitting it by bigram, I can put this is a sentence. So multiple bigrams are here. Similar way for the trigrams also, means consecutive adjacent words we are grouping and telling using this engrams. This is a sentence. So 3 letters if we group, it will be a trigram. We will learn in the next sessions how these techniques are used. Any questions on these two?
What is the difference between that word and unigrams? I think both are same, right?
Okay, so the tokenization, we have done the TF, IDF and vectorization and all, right? So this will be the initial step of that. So to split the word into each one. Here there will be a weightage. So we Here we are assigning, means checking the probability of that word occurrence. Both are similar. The first step is just splitting data. Here we can use it to check the occurrence of that particular word.
Okay.
Mostly, right? This doesn't gives a particular word doesn't gives a meaningful information. When you have multiple words together, it might give a better information. That's where higher bigram, trigram, and all will come into picture.
In the trigram, I can see that Isa is repeated.
Correct. It is adjacent words, right? Here also, this is Ise is also a bigram. Since it's not that meaningful, they might have skipped it. But any adjacent two words is a bigram. Any adjacent three words is a trigram. So these are so there are some specific words in natural language called stop words, which doesn't have any meaning or very little meaning. Like a and these articles doesn't have much meaning. Without that, also we can frame a sentence. So those words, we since it's not giving any specific meaning, we can remove it when we are doing the analysis, because not only this is not giving any meaning, there is a chance that this will repeat a lot, right? So this will impact our overall analysis. So as part of our analysis, we need to remove the stop words. So for that, we are using this corpus library. From there, we need to import the stop words. In NLTK itself, we have this libraries. So and it has different language, not only English, other languages are also there. So this particular command will list all the stop words in English. You can try with other language also. Other language also, I mean, Corpus supports other language as well.
It is importing stop word. Set stop word dot word in English.
It's just set, I mean, show this to display the stop words.
What is the next text area is the output, out 37, that is output.
Whatever A, about, above, after. That's that those are the list of stop words.
That is predefined stop word. NLTK is predefined stop word. A, about, after. Measuring word which have very little meaning such as they and
Sorry about that.
Yeah, okay, let's continue.
Sorry. There was some question on this, right? Can we continue?
Yeah, bless you.
Okay. Just execute and see this command. It will list all the stop words. Next step, next algorithm is stemming. So this also we might have used in machine learning when we did the project or those for the project, right? If anyone has done the text analytics, they might have used stemming and lemmatization. So stemming is a technique which will remove the suffix or prefix from a word. So it's just the getting the root word. So there are different types of stemming algorithm. In this, they have given us an example. So importance of caving as explained by K's. This is one text. So in that importance is A and C is removed and we have taken important. Off is off only. Caving, ing we have removed and put K. So those suffixes we have removed in this case. So in this table, they have given es, ing, ed. If there is a ed, that can be removed. Er. So all those things we will move it and keeping the first part. So here they in the stemming, okay, it will come. So there is a method called another algorithm called lemmatization. So in lemmatization, what they will do is they are converting the word. So if we have a word feed, it will be become food. Cacti will become cactus. Geese will become goose. Like that, here it will check for the context. In that particular context, what that word meaning is, it will check and then do the lemmatization. So this is the difference between stemming and lemmatization. Stemming, we are just chopping the word. So we will not check the context. We will just cut the word and take the first part of the word. It's basically a rule-based approach we are doing. So anything with ES, we will be removing. Anything ING, we will be removing. ED, we will be removing. So it's basically a rule-based approach. So for that approach, the accuracy is less. For example, when we consider studies, ideally studies should be converted to study, STUDY. But since this is removing the ES, it will be STUDI. So when this method we are choosing in some cases because this particular method is very fast. Whereas lemmatization, it's a dictionary-based approach where accuracy is more, but the speed is low. Speed is less. Any questions so far?
This stemming is used in the industry now, or is it an old something? Because it looks
No,
maybe
if there are means it will depend upon the size of data which you are looking and speed of processing. Still, stemming is used.
okay.
So if you want faster output, we might go with the, I mean, some error is fine. For example, for the spam detection use case, right? We don't have to mark everything as spam. The other way we may not allow, but for the spam, right? Whichever it is able to make sure it is a spam, it will make as a spam. But it doesn't have to give 100% accurate result. So such scenarios, we can still go with the stemming, where you don't need the 100% accuracy, right? Not even 100% accuracy may not be that feasible. Like 80% accuracy also is not needed. Then you can choose stemming because it's faster to complete.
Anyone here from the NLP background? Okay, yeah. Okay, let's continue.
Okay. The other one is POS tagging. POS stands for part of speech. So that's where I was telling, if you are from the literature background, the English you know well, you will be able to utilize this, because this part means there is a section, or 30% of NLP is more related to English or the language. So whoever is from the language background, they will be able to have a good advantage here. So this sentence, Alice wrote a program. Alice is a noun, wrote is a verb, A is an article, program is an adjective. So this tagging we will be doing. So the reason to do the tagging is in a sentence, when some cases, right, the same word can be verb and noun, means in different context. So to identify such things, we need to first do the POS tagging. Then only we can take it to the next, take it to the next step. The other one is named entity recognition. So here, this in English we have this name, place, thing, that categorization, right? It's similar to that. If North America is there, it's a location. More than 50%, it's a person classification. Like that, we are classifying. We will go through that India text and identify the words like North America 2007 AA. So wherever we can classify, we will classify whether it is for example, Google, IBM, Microsoft, these are all organizations. So that classification will be done when we are doing this named entity recognition. So far we covered tokenization, engrams, stop word removal, stemming, lemmatization, POS tagging, named entity recognition. There are other methods as well. We will slowly take it up. Any questions so far?
No.
I'm good.
So under each of these techniques, right, we will see multiple algorithms. Like we were telling, for the stemming and lemmatization, we have multiple algorithms. Similarly, for each of these, we will have multiple methods to categorize. This is what we are doing. How we are doing will be the next. So this is the overall NLP workflow. So first we need to split the text into different pieces, remove punctuation, all those things. That will be done by the tokenization. Then we will be removing the stop words like a, the, and all those words. And then stemming and lemmatization. This is considered as a single category where the word will be reduced to base form. And then we will be doing the POS tagging. So identifying which part of the speech particular word belongs to. And after that, we will be retrieving the information from this. And whatever terms we have mentioned now, all these are important for NLP and information retrieval as well. Okay, these are some of the textbooks we can go through for this NLP. If we are choosing the NLP, right, we can go through this. I think which is giving the this one Daniel Jurafsky. This is the author they are recommending. I have put the link, whatever I have covered so far, right? I have taken from this link. You can go through. It's a good video to start with.
ഞാനും ആദ്യമുണ്ട് ഞാനും ആദ്യം നീങ്ങിട്ടത് ഞാനും ആദ്യം നീങ്ങി കളിച്ചു പക്ഷെ വൈകിട്ട് സാറോട് വൈകിട്ട് ഉണ്ടായിരുന്നു വൈകിട്ട് 13 വരെ ഞാൻ പ്രൈമറി ഹൗസ് വെച്ചു.
That's all I have for NLP today.
Veena, you're saying something that information retrieval versus NLP. No, NLP is related to language, and IR is anything, right?
Correct, but these techniques, whatever we are using, right, that will be covered as part of information. Finally, the information we need to get. So this will be covered as part of information retrieval as well.
No, in your NLP full flow, you are showing the last paragraph is that information retrieval. Then IR is a part of NLP full process flow, right?
If you take that umbrella, NLP and IR are different. Both are part of text mining, but to do information retrieval, we need to use these NLP techniques. So these NLP, whatever techniques we have for NLP, that will be used for information retrieval.
Yeah, then first actually NLP, all the techniques you have to apply. Thereafter, after applying those things for information retrieval, IR will come into picture.
That's correct. So if you see this, sorry. The start is tokenization. So from tokenization, it will go to stop word removal. First, we will split the word, sentence into multiple words. Then we will remove the articles. Then we will do stemming and lemmatization. Then POS tagging. And after all this, we will have the information retrieval.
But when here it is telling NLP process workflow, IR also coming one of the portion of NLP workflow, right? And
the result will be means the NLP is basically used. NLP is one of the technique used for information retrieval. Both are closely related. In fact, the other way means we are using NLP for. There are other methods also for information retrieval, but the NLP is the one of the major technique used for IR.
So still we are confused what to take, right? Electives. IR and NLP are related, so we need to take both. Then the big data and the SPA are related.
If we want to do the specialization, we can go with IR. If we are looking, means taking all the four subject, means NLP has only 3 credits and we need only 16 credits. So if we take all complex subjects, then it will be little difficult for us to cover. So, but if we have some time and we need specialization, IR is one good subject we can choose.